continuation of section 7.3, and we're solving systems of equations and with three variables, and we're using row echelon form, which is the stair step. All right, in this problem here you can see that we are missing a variable x in the second equation, but that's okay. Our goal is to develop this stair step here so that we can back substitute. All right, we need to get rid of this x. And in order to do that, we are going to multiply a negative times row 1, and we're going to add it to row 3. And the only row that changes is the third row. Our second row also stays the same. We're not manipulating that at all. And our third row, so negative, so what we're doing, multiplying by negative. Add. We don't need to multiply by a negative here. We can actually just multiply by a positive. I see that negative, this is a negative x, so we just need to add these together. Just add, simply add row 1 and row 3 together. These cancel here. You get 0x. You're going to add the y's together. That's 3y. We're going to add the z's together. You can see here in my third equation I don't have any z's. Negative 3z plus nothing is negative 3z. And equals and add negative 1 plus 1 is 0. All right, there's our result of adding the first and third equations together. Now what we're going to do is we're going to use the y here so that we can eliminate 3y. And what we're going to look at here is, so that was our first step. So step 2 would be to take negative 3 times row 2 and add it to row 3. All right, your first equation doesn't change any at all. Our second equation doesn't change any. And our third equation, if I multiply that third equation by negative 3 and then add, I'm going to get 0y, 0z, and 0. So we have 0 is equal to 0. So this concludes that we have many solutions. But here's how we have to write our equation. We just don't list many. We actually are going to come up with an expression that represents all solutions. So from this second equation here, I know that y is equal to z. If I back substitute now into equation number 1, then I can do this, x plus z minus 3z equals negative 1. I can actually solve for x. This would be x minus 2z equals negative 1, or x would equal 2z minus 1. So we know what x is equal to. We know what y is equal to. So what does z equal? Well, what we do is we just let z be some arbitrary point or variable a. And if z is equal to a, then y is equal to a. And x would be 2a minus 1. So final solutions here, I'll put them over here on the left side. We're going to replace a for each of the z's. We let z equal a. So it's x is 2a minus 1, y is a, and z is a. And so for all real numbers a, these ordered triples would be the solution. All right, let's try another one with many solutions. Here you can see that we are given an equation with 3 variables but only 2 equations. We still want to follow the same process, so we are going to take the x and try to eliminate my 2x. I can multiply by a negative 2, and let's just see what happens. So negative 2 row 1, add to row 2. My first equation doesn't change. My second equation becomes 0x, and I've got 4y plus negative y is minus 3y. I've got minus 3z after multiplying and adding. It's negative 2z plus negative 1z, and then negative 4 plus 1 is negative 3. Okay, what happens is I get down to this equation here, and I can go ahead and reduce this equation. So that was my first step. Now my second step, I can take row 2, and I can divide by negative 3, and what this will give me is, my first equation again remains the same. My second equation will become y plus z is equal to 1. I'm dividing by a negative. If I go back into this step right here in my very first step, if I take, that's 4 plus negative 1y, that would have been a positive here. And then the rest are negative, so I'm just going to divide by negative 3. Or I was dividing by negative 3. I just want to divide by positive 3, so we are left with y minus z. Let's go ahead and correct this. Y minus z equals a negative 1. I'm just dividing each of these by 3. All right, so here's what we've got. We know that we are going to have infinitely many solutions. I'm not able to reduce this down and try to solve for z. So we automatically will just say, well, z is going to equal a then. And if z is equal to a, then y is going to be equal to, if I add it over to the other side, a minus 1. And I back substitute for x to find my other variable. So 2 times a minus 1 plus a is equal to 2. So we've got x minus 2a plus 2 plus a equals 2. My 2's cancel. You have x minus a is equal to 0. So x is equal to a. We're ready to write our solution. Our ordered triple is a for the x value, y is a minus 1, and z was also a. So we just let z equal a so that we can back substitute and write an expression for our solution. And there you have it. All right, let's look at one little note here. If you have an answer that is 2a over 3/6 a and 2a plus 1 all over 2, what you can do is you can take each one of these and have a common denominator and multiply them by the same smallest multiple. So I would take all of these and you can multiply them by least common denominator would be 12. So this would be 24a. That would be 6a. And 12a plus 6. So here you can cancel that, and 6 goes into 12 2 times, and so 2 times the 3. And then you can take here, and that's 6, so that's 12a plus 6. That's just one way to do it. I also could have just multiplied by 6. So if I take 2a, 3a over 6, 2a plus 1 over 2, and I just multiply by 6 to make it smaller, see, we could have had answers of 12a, 3a, and 6a plus 3. So these are just multiples of. All of these are answers to that. All right, our last example. We're going to go ahead and use this x then. So row 1, you go negative 2, row 1, and add it to row 2. Answers, so your row 1 stays the same. And row 2, when I multiply this by a negative 2 and add it, I get 0. I get 48y. And I get minus 13z equals 0. Okay, so again, we're not able to go any further than this to solve, and so we automatically say z is equal to a. So then 48y minus 13a would equal 0. So 48y equals 13a. So y is equal to 13/48 a. Now what we're going to do is find x. So x minus 19 times 13/48 a plus 5 times a equals 0. This would be x. We're going to distribute here the 19 times 13, which is 247a over 48 plus 5a equals 0. We need a common denominator, so it's x minus 247a over 48 plus, and 48, we need 48 times 5, which is 240. We're just going to keep solving. Add these together, so x, this would be minus 7/48 a equals 0, so x equals 7/48 a. So we've got, for final answer, 7/48 a, 13/48 a, and a. So another conclusion to this would be if we multiplied them all by 48, so that would be 7a, 13a, and 48a. That's just another alternate form for our solution. And that's how you do infinitely many solutions. This is your assignment for the first section.